Tests for manganese ion. Manganese is a chemical element with symbol Mn. It is found in various salts like manganese chloride, manganese nitrate and manganese sulfate as manganese 2 positive ion. In group 4, manganese ions are precipitated as their sulfides by passing hydrogen sulfide gas through their solution. Our aim here is to test for the presence of manganese ions in a given salt. First, we look at the preliminary tests of manganese ion. Dry heating test. Materials required: original salt in a test tube holder and Bunsen burner. Procedure: take a small quantity of salt in a test tube, heat it over the Bunsen burner. The salt becomes brown or black on heating, indicating the presence of manganese ions. Flame test. Materials required: original salt in a watch glass, concentrated hydrochloric acid, dropper, glass rod, platinum wire loop and Bunsen burner. Procedure: take a small quantity of the salt in a watch glass. To this, add a few drops of concentrated hydrochloric acid using a dropper. Mix the contents of the watch glass using a glass rod to make a paste. Take a small amount of the paste on a platinum wire loop and introduce it into the oxidizing flame of the Bunsen burner. Green flashes indicate the presence of manganese ion. Borax bead test. Materials required: original salt, borax, platinum wire loop and Bunsen burner. Procedure: take a small quantity of borax powder in the loop of platinum wire by dipping it in the borax powder. Heat it in the flame of the Bunsen burner. Borax swells and forms a transparent, colorless, glassy bead. Dip the hot bead in the watch glass containing salt. Heat it again either in the oxidizing flame or in the reducing flame of the Bunsen burner. In the oxidizing flame, the color of the bead becomes pinkish violet when both hot and cold. In reducing flame, the bead becomes colorless when both hot and cold. Next, we look at the analysis of the manganese ion. Materials required: salt solution in a test tube, concentrated nitric acid, ammonium chloride, ammonium hydroxide, hydrogen sulfide gas, spatula, droppers, test tube holder and Bunsen burner. Procedure: take a small quantity of concentrated nitric acid using a dropper. Add it into the salt solution taken in a test tube. Boil the solution for some time over the Bunsen burner. Using the spatula, add a small quantity of ammonium chloride to the solution. Boil the contents again and cool the test tube in a beaker containing water. Then, add excess of ammonium hydroxide solution and shake well. Now, pass hydrogen sulfide gas through the solution. Manganese 2 ions present in the salt solution react with hydrogen sulfide to form a flesh-colored precipitate of manganese sulfide. Finally, we look at the confirmatory tests of manganese ion. Sodium hydroxide bromine water test. Materials required: salt solution in a test tube, sodium hydroxide, bromine water and droppers. Procedure: take a small quantity of sodium hydroxide solution using a dropper. Add it into a small quantity of salt solution taken in a test tube. Shake the test tube well. Manganese ions present in the salt solution reacts with sodium hydroxide to form a white precipitate of manganese hydroxide. Using another dropper, add a small quantity of bromine water to the precipitate. Manganese hydroxide reacts with bromine water to form a brown precipitate of hydrated manganese dioxide. Lead peroxide test. Materials required: precipitate obtained in sodium hydroxide bromine water test, concentrated nitric acid, lead peroxide, dropper, spatula, test tube holder and Bunsen burner. Procedure: Take a small quantity of concentrated nitric acid using a dropper. Add into the precipitate obtained in sodium hydroxide bromine water test taken in a test tube. Using the spatula, add a small quantity of lead peroxide into the precipitate. Boil the contents of the test tube over the Bunsen burner and allow it to cool and settle. Manganese ions react with nitric acid and lead peroxide to form a pink solution due to the formation of permanganate. Precautions: handle nitric acid and hydrogen sulfide with proper care because they are highly hazardous. Heating should be done very carefully.